Hello, Natalie Tarry here from Natematics. Here I'm going to take you through what an identity is and also put it into the context of a couple of questions here. The easier one is one that's on the screen at the moment, and there's one that's a little bit harder, which I will take you through. Now, as with a lot of higher level maths topics, the actual concept of an identity is actually quite simple. However, you then have to use all of the other skills that you've learnt to answer a question, unless it's one of the ones that are sort of the much easier ones at the beginning of the exam. But yeah, generally you've got to think, okay, what is an identity? What am I expected to do? And then work out which skills you need to be able to do that. Okay, makes sense as I go through the explanation. Okay, so here's a question. So it says find the values of A, B, and C, except there's only A and B in this one, for where 3 and then AX plus B brackets is exactly the same as 6x minus 3. Now, when I say exactly the same as, I'll explain that a little bit more now. I'm just going to move this over a little bit, so I'm kind of looking at myself, so to speak. Okay, that's better. So the first thing is then, well, what is an identity? So a sort of formal definition is, it's an equation that's true for all values of the variable. So we've got equation and we've got a variable in there. So a variable is normally represented by X, but it's not exclusive. It doesn't have to be X, but most of the time we tend to see X. It's the one that's commonly used. So basically it means it's when X can take on lots of values, okay? So I'm going to put that into context with some of the things you've already seen. Now, we represent an identity with those 3 lines. Looks like an equal sign, but it's not, so just be careful, okay? Now, for most, they might understand that they're the same, but you are a top mathematician, so you need to understand the difference, okay? So let's have a look then. So how is it different to equal to, apart from the extra line? Now, think about what you've learned in maths. You've learned how to solve equations where one side is the same as the other. So we've said, well, what value of X or P or whatever letter it is makes the left-hand side equal the left-hand side. Left equals the right, sorry. I'm not running a script. So, for example, solve 3x minus 2 equals 10. So here, what we're trying to say is there's one value of X that we multiply by 3, subtract 2, and we get 10. So X represents just one number that we don't know, and we're able to go and find it out using our skills. So carry that on, you find X is 4. Now, the first time you probably come across the fact that these letters can be something that varies is when you've got something like this. Now, where have you seen that before? Now, I've actually put it in a nice format for you, so you haven't got to do too much working out in your head, or on paper, obviously. What is that? If I said y equals mx plus c, remember you've got 4 letters in there, haven't you? You've got y, m, x, and c. So the m and the c are the things that are fixed for that line, equation of a straight line. The y and the x are the things that vary, okay? So, and again, putting it into words, because I think with a lot of the things with maths, to be able to understand some of the higher level stuff, it's thinking about the processes that are going on, rather than x and y's and whatever. So the y coordinates are found by multiplying the x coordinate and then adding 5, okay? So, oh, sorry, I actually missplit out on this. It said the y coordinates are found by multiplying the x coordinate by 3, the gradient, and then we add 5, which is the intercept. So here, x can vary. In fact, it does vary, because if you think about it, when you plot a straight line, x has lots of values, doesn't it? Okay, and you could carry that on ad infinitum. So here, x can vary, and then so will y. So that's kind of giving you an introduction to when actually X when it is a variable. So you see, with letters, we learn them in different stages, and it's understanding the uses that they have in different applications of maths. Okay, so this is a really key thing to think about. So let's go back to our question. So we need to get both sides of the identity to be in the same format. That's going to make it a lot easier for us to be able to identify where A and B are. And again, ignore C. That was an example I was going to do, but I've now changed my mind. So let's have a look then. As with any maths question, it's like, well, okay, I know what I've got to do. I've got to put them I match them up a bit. But I don't know how to do that. Yes, you do. You've got to think, what can I do with what's in front of me? And those who've known me a while know I have these things I call Natalieisms. So it's like, well, what maths can you do with what's in front of you? That's normally a good start. So on the right-hand side, we've got a variable. We multiply it by 6, and then we subtract 3 from it. So what we're going to have to do is find something on the left-hand side that kind of looks like that. So we're multiplying a variable by something, and then there's something at the end afterwards. Okay, so let's have a look then. We've got some brackets here, haven't we? And we can expand those by multiplying what's outside, multiplying what's inside. So we do that, we get 3a times x, and I've made sure that I've got the curly x here so you can identify that it's a variable, not just a multiply sign. So let's have a look at what we've got here then. So what values of a and b, what must they be equal to, so that we have the same on the left-hand side as that 6x minus 3? Well, let's see what we can match up. Now, I have got one. Have I got it here somewhere? I did one for somebody earlier on, and I actually highlighted it. Let me just show now. I actually just highlighted it. I don't know whether you'll be able to see this actually on my camera, but I just used like highlighter pen to sort of highlight, you know, when you did the earlier stages of algebra where you were matching, collecting like terms, if you colour them in the same colour, sometimes makes it a bit easier to kind of match things together. So again, you might not need to do that, but just a tip if it does help you. So we've got here 3ax and 6x. So we've got something multiplying this variable on the left-hand side, and we know it's got to be equal to 6 because these have to match. So therefore, 3ax is identical to 6x. So therefore, 3a is equal to 6. We've taken the variable out of it now, so we've just got an equal sign in there. So 3a equals 6, so therefore a is equal to 2. That's it. Can't be equal to anything else, because otherwise it wouldn't be an identity. Okay, there's only one value a can equal. It is a constant. So therefore, let's have a look what else we've got. We've got 3b and we've got a minus 3. So these two things on either side that don't have a variable in them, they are matching together. They have to be the same as well. So therefore, we can take that out on its own and we can say that 3b is equal to minus 3. So again, just doing a little bit of manipulation there, we find that b is equal to minus 1. Done. How do you know you've got this right? Let's have a think about, and I'm not going to tell you straight away because I'm going to do this on the next example. So have a think about how can you check that that a equals 2 and b equals minus 1 are correct. Right, I'm going to go on to the next one. Obviously, you can always pause it at this point if you want to. So question number 2 then, this is a little bit harder. So find the values of a and b in a, x plus 4, plus b, lots of x minus 3, is exactly the same as identical to 10. Need to have a look at this now. And what do you notice about it? Is there anything that looks a bit different? Anything that you might be expecting in there that is not there, or something extra in there that you weren't expecting? I'll see if you're correct in a minute. Hopefully write that down and see if we agree with each other. So as with everything, we know it's an identity. We've got to match something on the left with something on the right. Right. Looking a bit not sure on this one at the moment, but Natalieisms, what do I say? Is there any maths you can do? So if it's not quite so obvious, think just, well, what maths can I do? So we've got brackets there, multiply out those brackets. So ax plus 4a plus bx minus 3b is identical to 10. Now what I've done here is I've noticed I've coloured them already. I've put the two things that are variables in red. And I just said group similar terms together. So just like when you used to collect like terms, I've actually physically put them together. And that's something I suggest to in foundation level, actually move them and put them together, because again, it's sometimes easier to see. Colouring them is enough for some people. Putting them together is sometimes the next step people need. So ax plus bx is my variable bit. And my constant bit is, I'm going ahead of myself here, the 4a minus 3b. So all of those four terms have got something we don't know in, haven't we? But yet all we've got on the right-hand side is a 10. So, okay, there's no x's for me to match up. I've got, what am I going to do? So there's no variable on the right, is there? There's nothing to match up to. However, this is a little trick. Maths is full of tricks. Maths, and these, again, the more you practice these things, the more you practice these questions, the more you practice past papers, the more this sort of tricks, these little tricks that make life easier for you will become second nature. Believe me, I've been there, I've done it, I've been through the pain. I've now come over the other side to help other people. All right. So what we can do is we can say, well, ax plus bx is identical to 0. There's nothing there, is there? There's no variable on the right-hand side, so it's 0. Little trick, make a note of it. Put it on if you've got little index cards or something, just make a note of it. So if it's not there, there's nothing there to match to, it must be 0. There is a calculation that must have gone on. It's now 0. So therefore, a plus b must be equal to 0. Whatever those numbers are, we know that they cancel each other out and they leave no variable on the right-hand side. Okay, that's fine. And I've just gone on to another slide now. So we'll just leave that bit there, a plus b equals 0. Now let's have a look at our constants. We've got 4a minus 3b is equal to 10. So let's just have a look at what we've got here now. Are we able to find a and b straight away yet? Again, these little questions, I've got a little, I say it's little, actually, it's 2 sides of A4 now, but it's a big list of Natalieisms that you can go through. So if you're ever stuck, you think, right, can one of these things help me now? So look at it and think, well, what maths can I do? Well, what have we got here? We've got 2 equations, 2 unknowns. What is that? You can see there's a bit of a lag here. Hopefully this is going to work okay when it comes through. Simultaneous equations, isn't it? And again, you as I say to so many people, you've just got to learn your facts. You've just got to learn your facts so that you recognize things like this. So yeah, it's not on a simultaneous equations question, but it's like a problem. You don't know what skills you're going to need to use until you actually get into the maths. So here we go then. So let's label our equations 1 and 2. Okay, so then I'm going to go through it as I would teach simultaneous equations, and I am aware the person I'm recording this for actually has just done simultaneous equations, but obviously any of my students in the future might not have done this, but hopefully you have by the time you've done identities. So from 1, we can rewrite that and say a equals minus b. So we've got an equation in a. You could do b if you want, it's entirely up to you. I've done that one. So I've called that equation 3. And then I'm going to substitute equation 3 into 2. Using this notation, if you've never seen it before, it was one that I was taught when I was in secondary school. It just helps, it makes it easier for you to sort of say what you're doing. So 1, I'm sub 1 into 2, or sub 3 into 4, or you kind of know what you're using. It just makes it easy to follow. So therefore, we're going to substitute a equals minus b into equation 2. So we've got 4 lots of a minus 3 lots of that, 3 lots of minus b, is equal to 10. Now I've just noticed something here. Anyone notice anything? I'm going to come back on and I'm going to add the next bit on. I'm not going to re-record it again. I'm just going to add it on in a minute. All right, back now. Bye-bye. Actually, I didn't even need to do that. I was looking at the wrong letter. I thought I'd put the negative signs in the wrong place, but I hadn't. So it's always good to check these things as I'm going through them. Because at the end of the day, I'm not a robot. Sometimes when I'm going through something, I drop a negative sign, so but at least I check it afterwards. So anyway, let's go back and this is actually correct. So we've got -4 lots of b. Substitute that into there. Minus 3b equals 10. So therefore, rearranging that, you have b equals minus 10 over 7. Right. So what can we do now? We can then substitute that back into here, can't we? So we know that if we know b, we can now say that a is equal to negative b. So -1 times b. Another tip to think about, actually. What is minus something? It's -1 multiplied by it. Another useful tip to add on. Another useful tip to add on. These things are just fun. Me have a bit of a laugh when I'm doing these. Okay, so substitute it in. You have a equals minus 10 over 7. So those two negatives become a plus. So we end up with a equals 10 over 7 or 10/7. Okay, so think back to what I said to you on the last question. How can we check that that is correct? Guess what? Here's one that I'm going to do with you now. So let's check it. So we found these values of A and B that using math skills that we know are valid, as long as you're following the right rules, having confidence in that you're following the right rules, that you're using rules that are, you've been taught they're correct, that they should equal, shouldn't they? The left-hand side should equal the right-hand side. Now, if you are going on to do A-level maths, there are quite a lot of identities that you come to do, trigonometric identities. And I always remember my teacher at A-level said to me, just look at one side. So just say, well, let's look at the left-hand side and then see if, after sometimes 2 or 3, 4 pages worth of proof, it ends up being what's on the right-hand side. And that feeling of when you get there is like, you really feel like you've achieved something. So anyway, even if you're not doing A-level, you've still got to do this. So let's expand the brackets out. Not expand the brackets out. Let's substitute in A is 10 over 7. And then B is minus 10 over 7. Well, that's what we think it is. So let's just check that we've done the right maths. So let's just look at the left-hand side, and I use LHS as a shorthand. As long as it's clear on what you're doing, it doesn't matter. So LHS, let's look at the left-hand side. So the left-hand side is equal to, just expanding the brackets here, we've got 10 over 7 times x plus 4 lots of 10 over 7. I'm just leaving it like that for now, because I think on these slides, when you've got somebody talking over it, you've got to obviously digest it as well as listen to me. So feel free to pause it at any time. We've then got minus 10 over 7 times x, which gives us that one. And then we've got minus 10 over 7 times minus 3. Now, useful tip, when you're multiplying things out and you've got negative signs, put some brackets around them. Another useful tip to add down to your list of things to not forget. Believe me, I do it. So, simplifying that, we have 10 over 7x plus 40 over 7. So when we multiply fractions, we multiply the tops, the numerators. Don't forget these basic skills. They come up in the harder questions. And then we've got, simplifying that, we've got minus 10 over x. And then you've got plus, because these two cancel each other out to become a positive, 30 over 7. Again, pause if you need to. Now, let's have a look. We've got plus 10 over 7x, and we've got a minus 10 over 7x. So they both cancel each other out, don't they? You're subtracting what you've already added in. So you're left with 40 plus 30 lots of sevenths, which gives 70 lots of sevenths, which is, remember that line in the middle? That's the same as a divide. A little tip for you. So don't forget that line in the middle of the numerator and the denominator means divide, which gives us an answer of 10. Now, if I was doing this, I just remembered I haven't put it in on my PowerPoint slide. I would just say, so therefore, left-hand side is identical to the right-hand side. Give myself a big tick. Okay? So that is how you would check. I hope that is clear for you. I have tried to give you a couple of thinking points in there as well, because at the end of the day, I'm just sitting here looking at my computer monitor, not getting any feedback from a student. If you were sat with me and I was explaining it, if you didn't understand something, you would ask. So as always, if you're watching this and you're thinking, I'm not quite sure how that happened, pop me a message, message me at natalie@natematics.co.uk, or message me via the Facebook or the internet page as well. I will get it from any of those, okay? But I know the person that I'm actually recording this for, obviously I've got direct communication with, and I recorded this on the 8th of August, 2021. So have a nice day, enjoy the rest of your day. Any questions? Let me know. Otherwise, thank you very much for watching, and bye-bye. Thank you.